Guys, hope all of us are doing great. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. In my discussion today, I'm going to look at the concept of a standard scores, and this, of course, are going to be given in terms of the Z scores. Now, this is going to form part of the data analysis procedures that we're going to use in comparing two observations coming from two different groups. Now, in this case, I've given these particular groups in terms of this stream. So in this case, my S is going to represent a particular stream given as stream 1 and stream 2. Now we can consider this one as an examination being undertaken by two specific streams or classes of 1 and 2, whereby the class 1 in that particular examination obtained a mean of 78 and a standard deviation of 6, whereas for class 2 or stream 2 obtained a mean of 90 in that particular test and the standard deviation of 5. Now we can consider this specific aspect of two sets of data, or a specific set of data coming from two observations, of course, being given as S1 and S2. And this is going to assist us, of course, give deviations from the mean in units of standard deviation. And of course, perhaps try to compare the number of particular deviations from this set of the mean given as such. So in this case, of course, we're going to use the concept of a standard scores in trying to achieve this objective of comparing the deviations from the mean in terms of units of the standard deviation, and also in trying to obtain the specific number of variations which of these specific scores are from the mean. Now in this case, I'm going to consider perhaps a specific set of two students from these particular streams, or this particular S1 and S2. So suppose a student in S1 scores a percentage of 95%, and perhaps a student or rather scores 90%, and a student in this stream 2 scores perhaps 95%. So we can of course determine the specific deviation from the mean of these two different scores, and try to see which among the two students scored better than the other one given that a specific set of data. Now this is going to be achieved through finding the standard scores, which of course means scores given also in terms of the Z scores given as such. So suppose we have a specific measurement from a distribution given in terms of X. So we have been given our particular distributions of X in terms of this general representation given as such. So suppose X represents a specific measurement from a particular distribution. We can give the mean of this specific distribution in terms of X with a bar given as such. So this is going to represent our mean, and the standard deviation is going to be given in terms of S for this specific distribution. So therefore we can find the relationship between this specific of course standard deviation and the mean in terms of standard score, and therefore we are going to have these specific relationships given in terms of standard units. So therefore for our population, we are going to give this standard scores Z given in terms of the difference between this specific value that I've given for the measures, and of course this particular value for the population all over this standard deviation for the population given as such. So this is going to give us the relationship of the deviation from the mean in units of standard deviation, and also give us the number of standard deviations of this specific set of data, and we're going to monitor whether it's to what extent it lies above or below a particular mean. So this is going to be for our population. And as well as we said, we can also consider the case of a sample given in terms of the standard scores for a sample can be given in terms of X minus the mean on over the standard deviation, the sample standard deviation given in terms of S. So basically it's going to be given for a sample, and we're going to sorry for that, use the two concepts in trying to compare this specific data and see who among the two students scored better compared to their specific scores of the particular groups which have been given for the two above. So in this case, we're going to calculate the standard scores using this specific formula for both students, whereby we're going to consider for student 1, then therefore we're going to use the sample, since we have chosen the two students from amongst these streams for the first one and second one, therefore we're going to use the formula for the sample standard scores given as such. So for the student from this specific stream that we have given in terms of 1, we can give it that particular case given as the mean or the specific value of that specific score for the first student or from the stream 1. So perhaps I can give it in terms of 1 so that we can differentiate between the various components that we have used. So that's going to be the mean for 1, and then we are going to, so the subscript that I'm using for 1 basically represents this specific score divided by the standard deviation that we're going to use for S1. So this is going to give us the value of, this is going to be the score, which is going to be given in terms of 9. So this is going to be representing the value of X, which we said is basically a particular measurement from our distribution. So the particular measurement from our distribution is going to entail the score of these two respective students. So for this one, we're going to have it given in terms of 90, and then minus the mean from that specific stream, which is 78, divided by the standard deviation, which is going to be given in terms of 6. So this is going to give us the value of 12 divided by 6, which is going to be 2. So this is going to be the specific number of standard deviations from the mean given as such. And then we're going to obtain the standard score for the second student given as well in terms of X2. So suppose we're going to take this specific value for 1 and 2, and we're going to have this specific score given as X2 minus the second mean given as that, divided by the standard deviation of the second one given as such. And this is going to be 95 minus 90. And of course, that's going to be divided by the standard deviation, which is 5. And that's going to give us the value of 5 over 5 equivalent to 1. So this one to be 1 standard deviation from the mean given as such. So this is going to assist us try to compare this the score of two specific students from these two distributions, and try to see who among these two students scored or had a better score as compared to the first one. So as we can see, of course, I mentioned basically that this is going to give us the standard values, or the Z values are going to give us particular deviations from the mean given in that specific quantity. And of course, we have seen that from this, the number of standard deviations are going to be given in terms of 6 and 5. But from the standard score as we have given, which are going to be given in standard units, of course, we can see that the first student basically scored better in terms of comparison with the mean as compared to the second student. And this, of course, is going to be one of the applications of the standard scores in assisting us trying to compare two different sets of data or observations coming from two different groups as I've mentioned. So basically, this is going to form a part of this specific discussion, last part of this specific discussion. And as we come by this specific aspect of the standard score, I presume that we are going to understand its implications in various sets of data given us, or data given as such. So that is it for now, guys. Bye, God bless you. Catch us in our next video.